Good morning, everyone. Welcome to our session for What's New with Fleet Indexing for AWS IoT Device Management. I am Alex Ha, Head of Product for IoT at Amazon Web Services. My co-presenter today is David Detlefsen, Senior Manager of Smart and Connected Devices at April Air. We are really excited to be up here today to speak about the major feature launches for Fleet Indexing this year. Let's go over some of the things we hope that you will learn with us today. First, I will recap AWS IoT Device Management and Device Defender, which are services that enable you to manage and monitor your fleets of devices connected to AWS IoT. And Dave will speak about April Air's technology journey with AWS IoT. Then I will introduce new capabilities of fleet indexing. Finally, we will talk about how you can get started with fleet indexing today. As your fleet continues to grow in size and complexity, AWS IoT Device Management and Device Defender can help you organize your devices, monitor fleet-wide state, manage the device lifecycle, and remotely troubleshoot any issues. AWS IoT Device Management comprises of three key components to provide you the ability to organize, update, and access these devices remotely for troubleshooting. So with fleet indexing, you can index device connectivity, property, and state data stored on AWS IoT Core, and use that data to search and aggregate metrics on devices. You can also use this index data to build query-defined device groups. With IoT jobs, you can create snapshot or continuous jobs to take remote action on individual or groups of devices, including rotating authentication certificates, updating device configurations, and disabling misbehaving devices. With secure tunneling, you can securely access devices behind a network firewall to remotely troubleshoot an issue. Together, these device management components enable your developers to build and maintain your own custom applications for managing your fleets of devices. AWS IoT Device Defender enables you to set up audits on your IoT resource configurations, set up cloud-side and on-device monitoring to detect anomalies, set up alerts via AWS IoT Console, Amazon Simple Notification Service, or Amazon CloudWatch. FleetHub is a fully managed web application that connects AWS IoT Device Management and Device Defender and provide you a centralized visibility to monitor your global fleet and identify any anomalies. With FleetHub, you can get visibility of the aggregate state of your entire fleet. You can monitor for operational issues and receive notifications to take corrective actions. You can also detect and diagnose issues with connectivity and take remote troubleshooting steps. Best practice from our customers who use fleet indexing and FleetHub is that more technical people can set up fleet indexing and jobs templates in AWS IoT Console, so that less technical folks can focus on their operational issues, such as troubleshooting, monitoring, or deploying updates through FleetHub. Now, I would like to walk you through key steps to use AWS IoT Device Management with fleet indexing. First step is fleet provisioning that helps you register your fleet of devices with AWS IoT Core. With fleet provisioning, you can generate and inject unique device identities on the devices, typically private key and X509 certs, and register device identities with AWS IoT, associated with appropriate permissions to the registered identities, also known as IoT policy. And optionally, create a virtual representation of devices in the cloud, such as things or things attributions. For customers who already have certain certificates generated and only need to register your device identities, you can use bulk registration to onboard as many devices as you want and making sure they are registered into AWS IoT registry using a Start Thing Registration Task API. Once your devices are registered, AWS IoT Console provides you basic search capabilities. Without fleet indexing, you can visit AWS IoT, then manage page, then things page. Then you can use the search box on the things page to search by thing name. With fleet indexing, you can use the advanced thing search page. For example, you can search for your light bulb's brightness is 72 in this screenshot. You can also use single search index API to handle all search requests and perform a cross-field search. Fleet indexing helps you to create dynamic groups to programmatically manage your devices. For example, you can create a dynamic group for brightness over 50. What this means is that whatever light bulbs brightness over 50 will be automatically part of this group, instead of you manually assign those devices to this group. And in addition, fleet indexing enables aggregation queries. That allows you to run a query and get common statistics in the search results. For example, aggregation count. How many devices are on firmware version 1.1 across a range of SKUs? Simple statistics. What's the mean time since last failure for all devices in the US? Percentiles. What are the bottom 5% of battery charge level of devices on your property? With aggregation queries, customers can now get fleet level metrics for understanding fleet behavior, defining alert thresholds, and automating batch remote actions. Aggregation queries also can be used to create dynamic groups or trigger alarms, and could be part of your Fleet Hub dashboard. One example would be to create a dynamic group for all devices reporting firmware version 1.1, and apply a continuous job to that group to update them to version 1.2. Searches can be run ad hoc from AWS IoT console or API or CLI. Once you have insights from fleet indexing and advanced search, you can use jobs to perform operations on one or many devices. Jobs is commonly used to run over-the-air updates. So basically, you can perform remote actions on device or in bulk, receive status updates for individual devices, control deployment velocity and set criteria, and digitally sign your jobs to protect your devices from being compromised. Lastly, secure tunneling allows you to remotely access your device behind network firewalls and troubleshoot their devices in the field. Key values secure tunneling provides are simple startup, install the tunneling agent on your devices, and launch your tunnel from the API or AWS IoT console. Remote management, access applications on remote devices using remote shell or remote desktop operations. And secure connection, manage devices authorization for each tunnel session using IAM permissions and configurable timeouts. Also, you can receive access tokens via MQTT messages. Now I'll pass it over to Dave to talk about April Air's technology journey with AWS IoT.
Good morning, everyone. I'm David Detlefsen, the Senior Manager of Smart and Connected Products at April Air. And April Air is a company that makes equipment that goes into your HVAC systems for residential homes. If you're a homeowner, there's a good chance that you may have some name brand recognition of April Air. Say, oh yeah, I think I have one of those humidifiers, for example, that is in my system. But at April Air, it's really easy to talk about being a purpose-driven company because we want to bring healthy air into every single home, especially with recent events. I think the air we breathe is so much more top of mind than it ever has been before. So as I said, April Air, we make residential indoor air quality remediations. which includes everything from thermostats and air purifiers, ventilation systems, things like that. Aprilaire is one of the brands that are owned by Research Products Corporation. It's about an 80-year-old company focused on innovation in this space. We love all of our sibling brands, but today we're going to be focusing on the connectivity of Aprilaire specifically in residential healthy air. You know, one of the things that we talk about often when we talk about the Internet of Things or IoT, right? There's usually either the smart flower pot, as an example, right? Or the thermostat, maybe the robotic vacuum cleaner, right? But we actually make that thermostat, right? We make the thermostat with the remote client on your mobile phone that helps condition the air around you. And it's a pretty interesting problem when you start to get into some of the details there. And then how do we also fold that into coordinating other aspects of air management with filtration and humidity, taking moisture in and out of the air to make things as comfortable as possible. Now, we started to do our connected product journey about 6 years ago or so, give or take. And we learned a lot, to say the least. And as I've spoken to other people here at this conference, talking about our journey and what we've learned, this is a very similar journey that other people have gone through as well, and maybe even yourselves. So I want to share some of the lessons that we've learned, and now talk to you also about how we're using some of the modern services like fleet indexing as well. I'll go through this somewhat quickly, not to get into too much detail, but for those familiar with the AWS icons, we basically started with devices talking to a hosted application and a database hosted by AWS. And through our success, we grew. And then all of a sudden, we had to take an application that was sitting on a single EC2, start to kind of break this down into sort of pseudo microservices. But we were just, too big for just one machine. But we still held that socket-based architecture, which didn't really scale all that well. And we just started scaling more and more vertically, horizontally, however we could, trying to keep up with the times, right? It's a good problem to have, but you could probably see where this is going, and it created some challenges for us. So in 2019, we decided to basically reinvent our whole architecture. And working with a great development partner of ours, Annika by Rackspace, we created a whole serverless architecture. We went full bore on AWS services. And while there's nothing so super revolutionary about having devices talk to IoT Core, having this stream of data come in through Kinesis and go into a DynamoDB table. The subtlety sort of comes in some of the lambdas that we do for data preparation and processing. We also have our data go into an S3 bucket so that we could analyze that later through Athena and be able to do some queries in Amazon QuickSight. And then we produce visibility towards that data through an API gateway for our mobile device. And if there are any questions, if you would like to talk to me afterwards, I'd be happy to talk to you about the lessons learned as we continue to go through this journey and device migration. But today, we're really here to talk about this core aspect of the IoT side, and that's fleet indexing. So let me dive into a couple of the business reasons on why we use this. So starting off from the business needs perspective, we do need real-time automated firmware updates. That's very important for us. We need disconnection analysis, and we always want our devices to be on as much as possible, of course, for the homeowner. And then finally, those darn marketers, right? Product managers are always asking us questions about how are our devices being used, and so we want to be able to answer those questions quickly and thoroughly. The importance of having real-time automated firmware updates is really coming from a thought that we provide a durable good. You buy it once and you want this thing to be in your home for several years, right? We're not a disposable product. So we really want to focus on the lifetime strategic value over that entire product, right? And so that requires that we add new features over time, and that's where firmware updates come in. So whether we're talking about improving performance, perhaps even individualizing certain algorithms based on what we could sense about your environment, these are all things that happen after you push updates to the device, not just something that you get out of the box. And speaking of out of the box, that's something that we've also learned is important. We make our products, we flash them with a particular version of OS, and then they go through our distribution chain, right? They may not reach the homeowner for several months. By that time, maybe we already have improvements. So almost by definition, somebody installing a new product of ours might have a version that's at least a couple of major or minor points of revisions behind what we have now. Any IoT device that you've probably set up in your home, the first thing that happens is, let's go get a new firmware update, right? So being able to have visibility to the firmware status of devices that are in our distributed fleet is very important. We needed an automated process that can push updates to our devices, and something that reduces the potential for human error, and something that could be automatic. All something that we were able to address. And through fleet indexing, we were able to understand when one of our devices connects to our platform, we automatically put it into a group, a dynamic group based on its model number and reported firmware version and hardware version. We are able to kick off an automated over-the-air update job like Alex was talking about, and then do this file transfer where we push down the proper version of the proper file of the proper firmware to the proper device all the time. And as a business result, right, a customer can install a new product any time of the day and instantly get the upgraded firmware that they need without waiting for us to batch process, wait for everything, and push these things forward. Also talking about disconnection analysis. You know, we always talk about how important it is to capture online data and how valuable online data is. Not many people think about how important is it to understand disconnected data, right? Customers are going to want to know if their devices go offline, right? Is my lake house freezing, right? Or is the humidity too high or too low in my wine cellar? If I can't get that information, then I need to be alerted about that. Customer service has come to us and said that they want to be able to troubleshoot why a customer might have Wi-Fi connection issues. And then finally, engineering, right? We want to work on statistically driven decisions, right? We want the data behind it to tell us what is really going on. So we set up, with just a couple of clicks, our own Fleet Hub application, and we immediately started to see this data coming out, how many devices were connected in our groups, and even the nature of our disconnections, whether they be server side, device side, and getting some of those insights was really quite easy and very valuable. Finally, talking about answers or being able to answer the questions that come from marketing. What features are most and least popular after installation? Should we continue to invest in certain areas, or are those areas never being used, or do users not even understand those features are there? Have the installers or the contractors put in the equipment and set it up properly in the first place, right? We don't install our products. We rely on building contractors to do that for us, and we need them to make sure that they do a good job at that. Very, very oftentimes they do, but if something is wrong, we want to be able to detect that and fix it for the customer. What energy savings plans might be available based on someone's region, seeing how energy usage is being used in their home, and can we offer more value to our customers by potentially saying, we see that you are now saving energy. That's great. Did you know that your village or your town or your city offers certain opportunities for, I don't know, tax incentives or something based on this, right? So preemptive advertising and communications all come from being able to track and segregate the types of devices that are being used in our fleet. So let's see. So in conclusion, if you're probably here because you have some sort of IoT device or interested in connected devices. Those devices are shedding data all the time. But the device data in itself is not as valuable as the information that comes from that data. Fleet indexing for us has been able to transform that data into actionable information. And once you have that information, now you can have the knowledge of what is the behavior of your groups, what is the behavior in the population of your groups, especially in widespread commercial distributed devices across the entire country. And then you can take proper action. And when you can take proper action towards a valuable problem, that is what leads to a favorable business outcome. And so device data is absolutely very important. It's fundamental, but it's really that next step to know how to turn that into actionable insights. And so with that, I would say our AWS journey still continues. We're still learning a lot, and we're very happy to be able to use some of the newest features that are in fleet indexing. And with that, I will turn the floor back over to Alex, who's going to tell you about some of the new stuff coming up. So thank you very much.
Thanks, Dave. Now, actually, let's talk about 4 new features we have launched for fleet indexing this year. So first feature is fleet metrics. Simple 2 steps. First, you can set the aggregation types such as statistics, cardinality, or percentiles. Perhaps you remember them as I mentioned earlier of this session, that APIs are also available for them. Then you can build aggregation queries whose results are continuously emitted to CloudWatch as metrics for analyzing trends and creating alarms. Now you can use the result in Amazon CloudWatch metrics. With fleet metrics, you can achieve monitoring use cases and potentially leverage other tools to set up alarms and take actions. For example, review my fleet disconnection rate in Seattle in the recent 2 weeks. Display devices average battery level changes daily. Track the temperature trending from my sensors for the last 3 days. In addition to the 3 application programming interfaces such as get statistics, get cardinality, and get percentiles I mentioned with fleet metrics, we are also introducing the 4th API, which is called get buckets aggregation. So this API and the get buckets aggregation, CLI returns a list of buckets and the total number of things that fits the query string criteria. The following example shows how to call the get buckets aggregation CLI. So query string, the query used to search the index. You can specify asterisk to get the count of all indexed things in your AWS account. Index name, the name of actually index to search. The default value is AWS things. Aggregation field, the field to aggregate, bucket aggregation type, the basic control of the response shape and the bucket aggregation type to perform. So this command returns the following. So you can see the total count 20 and buckets and key values 100, then count 12, key values 90, count 5, etc. So now you have the ability to group devices by a particular attribute, property, or other metadata using the new buckets aggregation query type, API, or CLI. The third new feature of Fleet indexing is disconnected reasons. In fact, this feature has been available, but now we extend to retain status of the Fleet indexing historical events up to 30 minutes. With this feature, you can search for a device based on a new disconnected reasons data field that provides additional insight into why a particular device lost its connection to AWS IoT, helping your fleet managers better diagnose connection issues across your fleet. The last new feature today is that fleet indexing can help you perform queries, target devices, and gain greater operational insights based on data stored in IoT core named shadows and IoT device defender violations. If you are not familiar with the term shadow in AWS IoT, just in case, there are two types of shadows. Classic shadows provide you extended capabilities to device-side information. For example, more attributes can be updated through MQTT, standard data structure using desired values, or a delta between a reported value and a desired value. Name shadow lets you truncate data size because less document actually size saves your cost. For example, air conditioning can be a name shadow of a car, which can be a classic shadow. So fleet indexing already supported classic shadow, and now we are extending our support for name shadow. Perhaps now you notice that the green tag in the top right says public preview, which is different from the orange tag says generally available. Let me actually go real quick to compare. So this one is orange generally available, and this one is public preview. And then, I'd like to share a couple of notes from the public preview. I promise this is only a word slide in this session. So basically, index updates from the above data, both the name shadow and AWS IoT device defender. They are free. Index updates from those data sources are free during the preview, but will be charged at a set price after the preview. And then search queries are billable regardless of the data sources at the current fleet indexing and search price, regardless of the preview period. Also, the maximum number of name shadows per thing is 5, and maximum number of total data size for a thing processed by fleet indexing is 32 kilobytes. I will walk you through how this new feature works. First, you can visit AWS IoT settings and manage the fleet indexing page. Then, you can enable name shadows or device defender violations based on your use case. There are 3 key actions you can perform from this step. You can create a thing group, perform advanced search, or aggregate queries. Let's create a thing group first. So I named it a device underbar in underbar high brightness in the upper section. Chose lights reported brightness property in the drop-down query field in the middle section. Then click the create thing group button in the bottom. Now you can see details in the thing actually group you created in the things group page. Perhaps you remember I mentioned earlier that more technical folks can set up fleet indexing and jobs templates in AWS IoT console, so that less technical people can focus on their operational issues, such as troubleshooting, monitoring, or deploying updates in Fleet Hub app. In conjunction with new fleet indexing capabilities, we are introducing a new fleet hub menus as well. So in the fleet hub dashboard, you can see alarms in the right side on AWS IoT, device defender, violations data. You can also click device list button in the middle left for the list menu. Then you can visit this page. So you can use predefined queries when you create a thing group in AWS IoT console that I showed earlier. Or you can add filters by using drop-down menu from name shadows or AWS IoT Device Defender for advanced search or aggregation queries. Then search results will appear based on your filter. So let's click Wind Turbine 2 to see details in the list. You can visit this page and see behavior violations on a specific device, which is Wind Turbine 2 in this case. If you want to see its shadow file to see further details and take remote actions through AWS IoT jobs, you can click Reported Data button there. Then you can visit this page to see reported data with shadow types. For example, classic shadows includes details for the Wind Turbine 2 itself. Name shadow cover details for engine of the Wind Turbine 2 because you created this name shadow with fleet indexing in the AWS IoT console before. Let's click the engine name shadows. Now you can see engine name shadow file for Wind Turbine 2. After checking the shadow file, you can run AWS IoT jobs to update firmware or perform a test to address your concern. In this example, you selected Wind Turbine 2, snapshot execution type, and provision device to add standard Xfinity profile to user's router. Let's recap what we have covered today and how we can get started with fleet indexing and Fleet Hub for AWS IoT device management. So fleet indexing helps you search devices by coding the index based on the last reported attributes or a state. For example, you can find all devices manufactured after 2013 with firmware version 1.2 that are currently connected. You can also automate your device organization with dynamically updating groups of devices based upon queries. For example, you can group all hardware version 1.1 light bulbs that are in New York. And you also can use aggregation groups. And with fleet indexing, you can also use Fleet Hub to gather insights into your fleet, such as building aggregation metrics and viewing aggregate device state to make better decisions for managing your fleet. And receive notifications when there are operational issues, such as receiving a notification when greater than 10 sensors low battery level. And investigate and triage connectivity issues, such as which thermostats in your office building have recently lost connection. From there, you can take corrective action, update firmware or software on devices, or remotely access devices to investigate and triage issues. Let's recap key benefits of the new fleet indexing capabilities. So first, you can build aggregation queries whose results are continuously emitted to CloudWatch as metrics for analyzing trends and creating alarms. Second, you can group actual devices by a particular attribute, property, or other metadata using new buckets aggregation query type or an API. Third, you can search for devices based on a new disconnect reasons data field that provides additional insights into why a particular device lost its connection to AWS IoT. With these three new features, you can index and query more data related to your IoT devices in a scalable way. And then now I just walk you through the fleet indexing for name shadows and IoT Device Defender violations, which is currently public preview. So now let's talk about what's new with AWS IoT device management, other than what we just covered today. There are three key new features. So first one is the proof of concept with AWS IoT device client. You can now build an IoT proof of concept that can take previously weeks now or even months, but now it can be done in just a couple of hours. So with the lightweight AWS IoT device client, you can launch a POC on an embedded Linux device. And by default, it enables you to connect, operate, manage, and control your fleets, or secure them against threats using AWS IoT services. It is open source, so you can actually modify it to fit your business needs when you scale up from a POC to production. Next one is jobs templates. You can define the remote operations for your IoT device fleets in templates that can be deployed to IoT devices by semi-technical operators through FleetHub at a later time. Last one is AWS managed templates for IoT jobs. So you can deploy common remote operations such as reboot, install, uninstall applications, start, stop services to manage your device lifecycle in a standardized and secure way. We also have resources on our website if you like to learn more about other AWS IoT services or resources or training programs for certification. And then also there are the related AWS re:Invent sessions this week. So first one is simplifying device security with AWS IoT. Second one is identify top IoT security threats using AWS IoT Device Defender. Third one is how to quickly build an IoT proof of concept with AWS IoT Device Client, which I mentioned earlier. And implementing a zero trust security model with AWS IoT. And lastly, how to manage your IoT devices at scale. So most of them will be happening tomorrow. So hopefully you can actually visit some of them if time permits. And thanks for attending our session. And please complete the session survey. And then now we are open to take any questions if you have.
Sure. I'm sorry, can you repeat the question, please? 'Cause we don't have a microphone, so I'm just going to ask you to. So we.
Can you repeat the question?
Oh, yeah. Okay. So thank you. So the question was, how many scheduled updates do we do per day? Scheduled updates per day. And how do we manage the costs of those? Okay. I'm sorry. Shadow updates. Okay. No, I got it. So right now we are, on a daily basis. I know that we're getting probably about 10 to 20 million shadow updates a week, right? And so the cost of that is I mean, you could look it up on any kind of cost calculator, but it's very reasonable within our budget. All of that traffic is still a very reasonable cost. I will tell you that according to our first architecture that I shared with you, we're reducing our costs probably 75 to 80% going serverless. So it's a significant return on investment. Yeah.
Actually, in addition to what Dave mentioned, that now we are introducing. I mean, the name shadows are available too. So name shadow actually can be a great way to save your cost as well, because it actually reduces the total document size of your devices.
So at the last count, we were close to 70,000 devices that were actively in the field, connected at any one time. There are devices that go online and offline. So the total number of devices in the fleet can vary. But we are also anticipating many devices that are in our distribution pipeline as well. And so as more houses are being built, as more pieces of equipment are coming on board, that number is growing steadily every week, which we're very happy to report. So,
Can you repeat the question? I mean,
oh, yeah, I'm sorry, I gotta keep repeating the question. Thank you for reminding me. All right, so the first question was how many, total devices do we have under management? And then, have we ever found something where, costs, get out of control? But accidentally, right, through, because everything is cost per usage, right? So we actually, it was not related to fleet indexing. The short answer to your question is no. We've never had any kind of runaway costs for fleet indexing. We did run into a bit of a sticky wicket once on our older platform with databases and something where we didn't have something entirely tuned up properly. And we got a little surprised at the end of the month, but not related to indexing.
I mean, in addition to what Dave mentioned, that so that's one of the main reasons why we are in fleet indexing now supporting name shadow as well. Because previously, if you use classic shadow to use fleet indexing, then every time you index, entire document size will be indexed and charged. Now you can define the subset of your entire document by allocating, for example, previously you have a car, so your classic shadow document size is, let's say, 32 kilobytes. Now you can actually define name shadow for air conditioning or name shadow for lights indicator. Then in each name shadow, the document size can be much smaller, such as like 4 kilobytes. Then whenever you use fleet indexing for those name shadows, the total billable document size would be much less.
I do want to build on one more thing because I just remembered. So we did get burned on that once. Afterwards, we set up going into AWS billing, right? Setting up a monthly budget per service is also very easy to do. And so now there are projections where if you are projected to hit your budget by the end of the month, you automatically get an alarm. And so that has now brought more visibility to make sure that we don't get caught by surprise anymore. So you could always look into that if that's something that it's a very valid concern. I can't. No, it's much. I mean, it's pennies on the dollar. I could follow up with you later, and we could talk about more in detail. But fleet indexing is not by any stretch of the imagination the biggest part of our costs. Yeah. Mm-hmm. Yeah.
Any other questions? Sure, please.
So we are indexing. We've set up an index on the shadow itself. We've also set up types of indexing. So when devices connect, right, especially for the there's device attributes, right, that you could also index off of. So we index off of the device attributes. We also index off of device properties. And a lot of times that's for those marketing questions that marketing wants to come off to ask about as well. So we do a combination of both.
Sure, please.
So just to repeat the question for those online, talking about what do we do for sort of visualizing device management across the entire fleet. So our first approach was to create CloudWatch dashboards, which provide probably the most holistic view of our entire platform, our Lambdas, our DynamoDB access, and all of that stuff as well, right? We then moved over to the Fleet Hub application specifically to answer what that application does very well. And so now we sort of have two dashboards, but the Fleet Hub is not meant to look at the diagnostics of our whole end-to-end pipeline. We do use CloudWatch for that, if that makes sense, right? There's other services that are monitored through CloudWatch.
Yeah, adding to what Dave mentioned, that that's one of the reasons why now Fleet Indexing supports Fleet Metrics. So now you can emit any data source available through Fleet Indexing to feed CloudWatch, so that you can have one holistic visibility there. However, Fleet Hub application itself still provides specific visibility on specific use cases. So you may want to keep Fleet Hub app for that visibility as well. Any other questions? Oh, please.
How do you sell this technology to the world of implementing the solution?
Well, okay, so I think that it helps that our company understands that a connected strategy in the smart home is fundamentally something that you have to participate in, right? So I can't say that I convinced the executive leadership that the smart home is a real thing, right? I'd like to take credit for that, but they already know, right? The smart home is a real thing. Now, when the mandate came down that we shall be a valid leading player in the smart home in our space, that's where we said, how do we do it smartly? How can we go into this? And how do we start to move fast and learn, right? Look at our journey, right? We didn't do everything right the first time. And if, we had to reboot our whole system. So our management gives us permission to experiment and learn, right? But at the same time, we also have to deliver results. So having that combination of where you can have really clear metrics and dashboards, management loves dashboards, right? So that helps tell the story, that helps sell the story. So Fleet Indexing, the Fleet Hub app, right? These are all ways that you can help communicate and sell your story.
Yeah, I think to what Dave mentioned that, AWS and AWS IoT, one of our goals is to provide you that visibility so that you can actually make data-driven decision making and onboard internal stakeholders and leadership to move toward cloud native and going forward. Because we do have visibility on most of our customers, how they use AWS and AWS IoT, and then how they improve their, their actually business and technology infrastructure going forward. So the smart home and smart factory, customers have been improving a lot after exploring all the options with us.
I would also say that, remember that pyramid, right, that I was talking about? Just make sure that if you're talking to a developer or an engineer, right, you can talk about the data. When you ask specifically, how do you sell this to management? Make sure that you're talking about the value proposition, the business outcome that you're going to deliver, and then collecting the data is just a means by which you're delivering that product outcome, right? Because really, what do they want? They want business results. And we are delivering that business result through an IoT technology. Yeah. There was, I think, a question here in the middle.
Right. If there's no other questions, I guess we can adjourn today. Again, thanks again for attending our session today, and hopefully we can keep in touch, and then we are willing to actually address any questions afterwards. Okay. Thanks a lot.
All right. Thank you.